Okay, so these are the 6 stages or 6 steps that we said that every company will have to think about. Every manufacturer will have to think about if they have to see how to balance what customers want and then how they should be able to keep their costs as low as possible. So that is where we were discussing how these 6 areas will help us. So products can be categorized, as I said, into make to stock and make to order, right? Those that are ready to be bought and consumed, those that can be bought over the shelf, we call it as make to stock.
Maybe no.
Right. Make to order is all those, all those products where there is a very high degree of customization and when there is very high degree of flexibility involved. We don't know what exactly the customer will come asking for. So we cannot keep all of that ready. So depending on those, which category your product will fall into, right? Whether it's a make to stock or whether it's a make to order, you'll have to take your decision accordingly. And as we understand, these are the various factors that influence process selection as well as the choice of the product, whether it is make to stock or make to order. It depends on these factors. It depends on the market conditions, which is demand. Then it depends on capital requirement. How much of capital do you have to invest in your business and in your production process? Third is the availability of labor. If labor is abundantly available, then it becomes a labor intensive unit. You can have more employees working. But if labor is not available in plenty, then you have to go in for a capital intensive. You'll have more machinery involved. And then management skills are required according to how technical your product is, raw material availability, technology available. All these are the same factors. Factors influencing plant location and all those factors that influence layout. So same factors are what we are considering. So right, that is what I was explaining to you all yesterday. Right. So how do you design a process? You determine which is the product that you're going to manufacture and whether it falls into that make to stock category or whether it falls under make to order category. And then you have to determine the path. Based on your layout, you have to determine what is the sequence, in what flow the operations are going to come. And then you have to align or assign, workers, tools, machines, equipments, all of that. And then you have to see how the entire production can be feasibly done in the given facility. Right. So that is where we also brought in the new product development process, because this goes hand in hand. Right. Though you study new product development as a series of stages in marketing, it has a very strong relationship with what we do in production, because when we look at product development, test marketing, right, all of that is something that is done by the production department. So the first 5 stages that you see are completely involved in the planning of the entire concept. Whether this concept will get accepted, whether the product has got utility, whether this design is okay, whether the shape is okay, whether the size is okay, what kind of customers will come, when will they come and buy, how will they come and buy, all of those detailing is what we do. Right. So all of that is what exactly is done in the first 5 stages. And then we develop a product and then we test market it and before we release it into the market. Right. So it's a very, very critical stage or a process that we take into consideration. So designing of the product is very important. First stage. Second is value analysis. After you start making the product, you start selling, you have to consistently try to see how to reduce cost. Well, the more you try to save in the production process, the more benefit you can give to the customer. Right. Like, for example, what is the logic when a lot of companies give discount to customers or they give price offs, right? They give you 70% discount, right? Or they give you price offs. The MRP will be something else, will be much higher. Will be, say, for example, it will be 550 rupees. They'll say the selling price for today is 420 rupees. So how are they able to give you that kind of a price benefit so that as a customer, you end up saving? You buy the same product, but you pay less. That happens through a process called value analysis or value engineering. The producer will be able to give a discount or whether will be able to give a price benefit to a customer only if he or she is able to reduce cost. And that happens through a process of value engineering. So what happens in value engineering is once we set up a layout, once we set up a sequence of machinery and the production process starts off, right? What happens is we constantly keep trying to see how we can reduce cost, how we can reduce time, how we can reduce the lead time, how we can save on the materials, how we can be more optimal, how we can ensure that wastage is minimized. As we constantly keep trying to see how we can bring about continuous improvement, we automatically will reach a point where we will be able to reduce the cost and then ensure that the customer gets the same benefit, right? And customer, as I told you, looks at 4 different types of values. One is cost value, which means what I pay as the price of the product, I should be able to get more benefit. Second is exchange value. If in case I want to sell this product, if I want to sell it in the second-hand market, or I want to give it to somebody else at a price, there should be a resale value, exchange cost. Third is we looking at use value, which is functionality, right? For whatever is the need for which I'm buying the product, I should be able to use it. And then fourth is esteem value. There is a status or there is a pride that is attached. You can tell people proudly, like, look, this is the product that I'm having, or so and so is having this brand, or so and so is having this particular product. So it increases your status. People will turn back to see, when you are having this product or when you're using this product. So people look for all of this, right? So we all keep this in mind when we go about buying these goods. The third thing by which you can reach that value analysis or value engineering to bring down your cost is standardization and simplification. Standardization is bringing about uniformity, because when you standardize the process, there is a standard operating procedure, then all the goods will be manufactured in the same type, in the same size, in the same weight, the same measure. So what happens is making of the product, storing of the product, transporting of the product, selling of the product, all of that becomes easy. Standards. That is why every time when you go to any store, when you want to buy, there's always a standard size. If you want to buy furniture, furniture is always of a standard size, right? Or if you want to buy racks for your kitchen, that is also of a standard size, right? So everything comes in a standardized manner, because when components and other equipments are made, components and other parts are made on a standardized basis, it can fit into anything. That compatibility factor will also be a good benefit. Second is trying to reduce unnecessary activities and unnecessary things. That is what we call a simplification. Trying to see how we can do maximum work with minimum time and minimum effort. So cut down all the unnecessary things and just ensure what is required is what we have, right? By ensuring constantly trying to see how we can standardize the process and how we can simplify the work process, we will be able to achieve that stage where we will be able to reduce cost drastically. The fourth important decision to reach value analysis or value engineering, trying to ensure product design, good product design and analysis, is this very important decision called the make or buy, right? Whether to make the product or whether to purchase it from an external supplier, right? So there are two things that you can do. You can purchase the whole product from an employer, from an external supplier. The whole product is manufactured by somebody else. You just take the product, put your brand name, and then you sell it. That's why a lot of times when you see, goods, any FMCG commodities, mostly if you see, or any other commodity also, you will see there will be two names of companies on the label. One title will tell you manufactured by, right? There'll be one address of a company that says manufactured by so and so XYZ company in Gurgaon and so on. There'll be another description that says marketed by. So very often the company that is marketing will be the company whose brand name is put on it. So made by somebody, marketed by somebody, right? So usually that is the case. So the whole product is manufactured by somebody. When it comes to your end, before you release it into the market, you put your brand name or you put that seal and then you sell it into the market. Or otherwise what we can do is we only outsource components and materials and then assemble it in our own plant. Somebody else does all the parts and then we bring it here and then we do that, right? So the whole logic behind the make or buy decision is to see how we can reduce cost. Whether you are able to make it on your own and reduce cost, or whether somebody else is able to make it and reduce cost much better than you. So make or buy decision is something that we have to look in, right? So there are a lot of factors that you need to look into, because initially it may look like a very prospective kind of a strategy, right? But this is not something for a short term. This is one of those very important decisions that a company takes. Once as a manufacturing unit, you decide you want to give the outsourcing to somebody. You want to outsource the whole product or part of the product or components of a product to an outsourcing partner, right? If you decide to do that, it cannot be rechanged or it cannot be reverted. That decision cannot be reverted after 1 month or 2 months. Usually these decisions are long-term decisions. Once you make a decision, once you give your know-how, once you share your technology, once you share your design with an external manufacturer, the outsourced manufacturer, then they get to know everything about what you have been doing in your company, right? So these kind of decisions are taken very carefully, and we take all of these matters into consideration, right? What quantity is involved? Will the drawings and other kind of design keep changing constantly? Whether we are purchasing these tools, equipments, and machinery, whether it is owned by the company or whether we've taken it on a loan, right? How is it done? And whether demand is fluctuating or whether demand is constant. Do you know that this exactly will be the same number of items that will be bought by the customers, right? And whether there is any patent involved, whether there is any copyright involved, right? All of these details are to be considered. And very importantly, what is the investment? What is the rate that the outsourcing partner is charging for one unit, and what is the rate at which you make the same item in your factory? What is the cost? There's a big cost difference, and if you are able to gain, or if you are able to get the benefit by outsourcing the whole product to somebody else to be manufactured, or a component or part to be manufactured, whichever the case is, if there is a big difference in terms of cost, if cost comes down close to by around 40% or 45%, it's a great deal, which means 50% of your cost is almost down. So you can play around with in terms of discount. You can give as many price offs as possible and try to ensure that more demand increases in your favor. So these are the kind of benefits that you will be able to get, right? We were looking at all of this, but you must be very careful about how we do this. Because once we make a decision, it's very difficult for us to revert. And especially when your product involves patents and copyrights, you have to share these secrets with your outsourcing partners, because they are going to manufacture. So if you don't share your patent, your patented design or your patented material or patented concept to the outsourced manufacturer, they will never be able to manufacture, right? So it involves a lot of confidentiality. And then what is the guarantee that the outsourced partner will not make similar products and sell it in the black market? That's also a huge risk that gets involved, right? So companies take a lot of time before they decide who they want to give this to and to what extent they will have control over it, right? So that is how they decide whether to go for manufacturing or whether to go in for buying, right? So you take all of these decisions into consideration and then decide what is the right thing that we are looking at, right? Now what ultimately we are going to decide is we are looking at the total landed cost, right? When you look at manufacturing of product, there are umpteen number of costs that come through the entire supply chain. Right from the time you start deciding on buying the raw material, right? Purchasing is one cost, and then transportation is another cost. Loading and unloading is another cost. Then inventorying in a warehouse is another cost. Inventory itself is another cost, right? So at every stage of your value chain, cost gets involved, cost gets added. So when it reaches a point when you have to fix the maximum retail price, the maximum retail price is fixed on the basis of the average cost of all the supply chain process that has taken place right from the stage when it began till the stage where it is ready to be supplied and sold to the customer. That is what we call as the MRP, maximum retail price. You understand that? So we are looking at the maximum retail price. So when you fix the maximum retail price and when you want to sell your product at the MRP, whether the MRP is the competitive rate with others in the industry, that is again something that you have to see. The MRP that you have fixed for your product, is it higher than what others are selling for the same product? Is it higher than the MRP that is fixed by the other companies in the industry? Or whether it is equal to what others have fixed as the MRP, or whether it is lesser. So that final cost is what we call as a total landed cost. So ultimately, whatever gimmick you try, whether you make it on your own or whether you outsource it to somebody, whether you outsource it wholly, whether you outsource it in part, whether you do value engineering, concurrent engineering, whatever drama or trick that is available in the books of production and operations management, Whatever you use, ultimately it boils down to that whether the total landed cost, which is the MRP at that point when you are trying to fix the MRP, whether it is the lowest in the market or whether it is equal to what others are selling in the market. Only if it is equal to what others are selling in the market, we call this as a competitive rate. Or when the MRP is lower than what others are offering it for sale, only then you get an advantage. If your MRP is greater than what others are selling in the market, then you lose. You lose even the customers who have been regularly buying from you, because they will start saying that the same product is available at a lesser price with competitors. So why should I buy from this company? They will slowly start leaving you and they will slowly start buying from the other competitors. So ultimately, whatever decision you make, if it does not make sense at the MRP level for a customer, then anything you do is an utter waste. That's why all of these individual factors that I've listed, all of that has to be considered before we decide as to what is the total landed cost. The fifth idea that we're coming to is ergonomical consideration in product design. Okay, so the customer is willing to pay a price, right? Pays a certain amount of money, buys a product. So you cannot decide to make a product that is anything. The product has to fit the human consumption or has to be used and handled and managed by the human beings, right? So you got to keep the person who is going to the user in mind when you are designing the product. I was giving you examples of the mobile phones, right? A laptop is also a very good example. A furniture is also a very good example. A chair that is designed ergonomically, right? It is designed in such a way that it considers the average height of a person. It considers the average weight of a person, right? It makes sure that the back that is designed, the back of the furniture is designed in such a way that it supports your spinal cord, right? The table is made at a certain height. It's neither too high or neither too small, because both will be uncomfortable, which means it is not ergonomically designed. So any product that you take, right? It can be a garment, it can be a cap, it can be a water bottle, it can be a mobile phone, it can be a chair, it can be curtains, it can be windows, or it can be a house. You take any product for that matter, you got to always keep the user in mind. Who is this person who's going to use it, and will that person be able to use this product? And based on those inputs, you have to design your product and to make sure that it is comfortable for any human being to use this under any conditions, right? So that point is very important. We call this as design, product design, or we call this as design thinking, right? We've got to design by taking the inputs of the user in mind and then making sure what is more good and comfortable for a customer. This is called ergonomical design. So when any good is ergonomically designed, it looks good. When you hold it, it's handy, it's comfortable, you can hold it, you can fold it, you can pack it. So a lot of things that you can make, that you can incorporate in the product, make it, because it makes it more user friendly, right? The word user friendly itself is associated with products that are ergonomically designed. If it is not ergonomically designed, nobody will say it's user friendly. So try to make the product as user friendly as possible, because the user friendliness itself will increase the demand for your commodities, right? So remember that. And the sixth last aspect that we're looking at is called concurrent engineering, which is called simultaneous engineering, which means what? Which means as in when your product is getting manufactured, or that particular layout that you've already installed and you're going around doing your work, constantly what will happen is there will also be a lot of development that will take place in your industry, right? Let's say, for example, I bought this laptop and I'm using it, right? While I am using only, there are so many other changes or developments that have taken place in the laptop, right? The same company has undergone a lot of changes. There are a lot of improvements that are made in the design. Improvements have been made on the functioning. Improvements have been made in terms of the longevity of the battery. Improvements have been made in terms of how fast and how quick the RAM and the processor works. So that is when, by the time my product is kind of getting a little lagging, and then I'm looking at a replacement, I have the next upgrade. So products that ensure that there are constant upgrades are constantly trying to bring about additional developments or improvements. Constant improvements are also happening. So As and when there are improvements that are taking place in your industry, in your field, in your respective sector, try to incorporate that in your production process. When you bring about all those improvements and incorporate that in your production process, when you bring something called concurrent engineering, automatically things will improve, right? So that is how you will be able to ensure that your good will go to the right customer. And as a producer, you will be able to make it at the most convenient price, at the most convenient option, and then be able to create a win-win kind of a situation. That is where I said yesterday that you must be able to balance, give what the customer wants, but also ensure that it is made at a cost that is more comfortable and more feasible for you, right? So if you're able to do this, you will be able to achieve those stages. So what are the different tools that we use in concurrent engineering? These are some techniques that we use. One is called QFD. It's called quality function design. Identifying all the various functions or features and then ensuring each of the feature is created for high quality. If, for example, a product has got 5 features, ensuring that all the 5 features are of good quality and ensuring that each feature is contributing to the functioning of the product. Then you have DFA, design for assembly. DFA is done in such a manner that when we outsource components and other parts to various suppliers, so there'll be about 5 or 6 suppliers who are making different parts. When we buy it from all these 5 suppliers, I should be able to assemble it together as one product. You understand that it's not just one manufacturer and one outsourced supplier, 5 or 6 or 10 outsourced suppliers. From whomever I bring it, I should be able to assemble it, right? It should become a whole product. Nobody should be able to know that this was bought from 5 or 6 different suppliers. That's called DFA. Then thinking about design for manufacturing, trying to ensure that we have the best manufacturing practice. Design for environment is ensuring that the entire production process is very environment friendly. We adopt green production methods, and then we use something called FMEA. FMEA is to make sure that we reduce failure and then try to see how the product can be manufactured in least failure or ensure that the number of parts that we manufacture, the failure rate will be much lesser. So by utilizing these tools, by applying the QFD, DFA, DFM, DFE, and FMEA, you will be able to understand where error is taking place or where improvements can be made. And in these 5 areas, if you're able to constantly see how you can improve, automatically you will reach that stage where you will be able to reduce the total landed cost, and you will be identified as one of those best and top producers or manufacturers in the country. Good. Right. So those are the 6 stages which talk about value analysis, which talk about product design and analysis. So how do you ensure design for function, design for making, design for selling? It's using these 6 stages. Okay. Right. Next, we're talking about another topic called vertical integration. Right. Now, what is vertical integration? When we talk about that make or buy decision itself, we are bringing in a whole lot of parties in the supply chain, right? A whole lot of parties. So it's not just a producer. You cannot manufacture a product all on your own, because not all services can be offered by you, right? So there are different parties in the supply chain, right? So let's say, for example, who are the various parties in the supply chain? Any one person can answer. Who are the various parties in the supply chain? Akshata, can you name some parties in the supply chain? Who are the people who are part of the supply chain? Akshata, can you hear me? Akshata.
Yes, sir.
Yes, Akshata. Yeah. Who are the parties in the supply chain other than the producer?
Retailers,
Okay, retailer.
then consumers,
Okay, consumers are not part of the supply chain. They are the users. Okay, retailer is enabling. Retailer is helping the producer to sell the product. Okay.
yes.
Who else? Okay, I have Ruben giving me some answers. So you have somebody who is a raw material supplier, then you have a distributor, then you have a wholesaler, then you have a retailer, then you have a transporter, then you have a warehouser. So everybody who's involved from start to finish. Manufacturer is just one end, one activity, right? You are purchasing. So there is somebody who is supplying raw material. There is another party who is buying raw material, right? Sometimes what happens is companies themselves, factories themselves don't buy raw materials. They appoint somebody. So there are distributors or there are suppliers, right? They are contract suppliers. So they buy from various other manufacturers and then they will finally supply to the uh, to the to the company, right? So you have so many people involved. You have uh, the raw material supplier, and then you have a raw material purchaser, then you have a transporter, then you have another set of people who are involved in the loading and unloading, right? So there is an agency that can take care of all of that, loading, unloading. Then warehousing is one activity. Transportation, again, finished commodities from the warehouse will have to get transported. Then grading of commodities. Certain times the goods have to be weighed. It has to be graded. It has to be sealed for quality accreditation, right? So all of these parties, right? So when we talk about manufacturing, like how somebody is put it in the chat from start to end, all those various parties, all those various businesses who come in between, we call it as a supply chain. So unless and until there is a good relationship among the various parties in the supply chain, we will never be able to achieve that total landed cost. Because if you're trying to do it effectively, and if your transporter is charging more, if your transporter is not optimally doing his job, or the warehouse is not optimally doing the job, so somewhere what happens is whatever you save, somebody else is ending up making it more expensive. So supply chain is very much like your relay race. It just does not depend on one individual who's running the final lap to say that I am the winner. It depends on all the parties in the supply chain. So when your raw material supplier, when your raw material company is supplying those raw materials, you need to negotiate to the highest possible extent so that you can get the raw material at the least cost, right? Second is when you bargain with your transporter, you have to make sure that the transporter is able to transport optimal levels, not half truck, but full truck, like that, or ensuring which is the mode of transport that is more cheaper, right? If transporting by lorries is expensive, then you have to think about whether transporting by railways is very cheaper. If you feel that the cost is much lower when you transport it by railways, then you should be able to switch, right? Like that, you got to constantly keep looking at trying to see how you can work with all your supply chain partners and see how you can bring down the total landed cost so that you will get that MRP advantage, right? That's why we talk about this concept called vertical integration, right? So it is an arrangement in which the supply chain of a company is owned by that company. Usually each member of the supply chain produces a different product. Like how I told you, there are different parties who are involved, but they're all coming together and trying to see how we can contribute and help the manufacturer and producer to achieve that particular stage, right? So there are two stages that we have, three types of vertical integration that we're looking at, right? One type of vertical integration is called backward integration, and then we have forward integration, and then we have both, a combination of upward, forward, or backward, right? The other term that we use is called backward linkage and forward linkage. Anybody has an idea what it is? Backward linkage and forward linkage? Or what do you understand by upstream and downstream?
So from producer to raw material acquisition is upward linkage, and producer to consumer is the downward linkage.
Yeah, very good. Now, why does a company decide to do this upstream, downstream? Why do you think a manufacturer wants to do this kind of vertical integration?
So probably to create a demand, like to know what the demand is in the market.
No, demand is anywhere out in the market. You are only trying to cater by making the products to cater to the demand. But why do you want to create a backward linkage? Or why do you want to create a forward linkage? Why are you getting into the job of doing something else other than producing? All right, now what it means, what we mean by backward linkage or backward integration or upstream. This means a manufacturer, right, who had earlier outsourced all the activities before the manufacturing, right? All the activities before manufacturing is purchase of raw material, transportation of raw material, warehousing of raw material, and then movement of raw materials to your factory. Only then it comes to your factory. At the factory is where you are converting. So all those supply chain activities before the raw material reaches your factory is what we call as the backward stream. It's called the upstream, right? Which some other party to whom you had outsourced was doing it. Sometimes what happens is when you feel that the supply chain partner is not as efficient or is not able to control cost or is not able to match up to your expectation, and if you feel that particular activity is very important, a company decides that let us take up this activity on our own. So let me give you another example. Like for example, if raw material, you purchase raw materials in one location in India, right? And this is a constant activity. You've been purchasing raw materials from 2 or 3 different locations in India, right? But the transportation cost has always been very high. And transportation, you have been relying on some transport company, and that company has been always charging very high price and they don't give you a good deal, right? And because of which almost about 60% of the money that you spend is actually going to pay the transporter. When a big amount is going to the transporter and you're not getting that benefit and you feel that the transporter is trying to have some control over you, the company at that point of time decides, anyway, since transportation is a continuous activity, instead of depending on somebody for transportation, why don't we own the transportation company? So if you're a big company, then you can buy the transportation company, right? So that what happens is the transportation activity is now part of yours. Or you can buy lorries on your own and then decide to take up the transportation on your own. So instead of depending on somebody, you taking it up. So when you are doing something in any one of these supply chain activity before the item or the raw material reaches your factory, we call this as backward integration. Forward integration or downstream integration is where you feel that instead of depending on somebody else to sell my good, depending on wholesaler, retailers, or trying to depend on other companies to sell the good, let me have my own showroom or let me have my own retail outlets. So all of those manufacturers who have their exclusive retail outlets, right, where they sell exclusively their products or they have complete control over the retailing format, that is what we call as the forward integration. So you have the supply chain, but at some point of time when you realize that some activity in the supply chain is not giving you the benefit, companies try to end up owning that activity or take up the responsibility of doing that activity on their own. So when it is before all the activity, if it is going to be any activity before the raw material reaches the factory, that is called upstream or it's called backward vertical integration, right? Anything after the commodity is manufactured, from the finished commodity stage, from the time it is ready to use at the factory till the time it reaches the customer, this is called forward integration or downstream vertical integration. So a company can do either backward or it can do forward, or it can do a combination, which means you are doing both upstream and downstream. That also you're trying to do so that you can have control over what you are doing. Okay, so these are 3 types of vertical integration that can help companies to see how they can further negotiate with the supply chain activities and then be able to fulfill that requirement of how to keep the cost very low. Okay, good. So with that, we come to the end of that particular topic. Anybody has any questions to ask me? Anything until that point before we go to the next topic, which is called the work study. So when we're talking about product design and analysis, along with the 6 points that we discussed, you can also include vertical integration. Vertical integration can be included as the 7th point to explain how product design and analysis is done, or the different factors that contribute for product design and analysis to ensure how we can reduce cost in production and operations. So you can include vertical integration as the 7th point. So that will help you to answer that particular question if at all that question is asked anywhere. Okay, now comes the next point. When we talk about work study, now we are coming to a micro aspect of what we decided in the layout, right? So one decision that we took was deciding where to put the factory. Okay, you decided where is the location. So you have something called a locational advantage. Second, after you decide where you want to set up your factory, second decision that you're taking is what is the kind of layout that you should have. A layout that is convenient, a layout that is optimal, layout that will help you to manufacture high volume goods in less time, right? So depending on the characteristics of whether it's a job shop or a batch production, continuous production, depending on that, you are choosing and deciding whether it's a product layout, process layout, combination, fixed layout, right? So you do all of that. Now, when you take one workstation, one particular activity in that layout, which is workstation one activity that you're going to do in the production process, right? You are very closely looking at that particular activity to see what is the time that particular activity takes. What is the start time and end time, right? That is one thing. Second, from the start to the end, how many units are manufactured? What is the quantity that you manufacture? Right? So two things that we keep in mind. One is time, and then we look at quantity, and then we try to see what is the cost, right? So actually three things that gets involved. So we need to study, we need to see what is the time taken for each activity, right? Find out what is the time taken, what are the different steps involved, right? And then try to see whether that particular time, we call this as the cycle time, but the cycle time can be reduced, whether it can be reduced, whether any one or two of the steps can be combined, whether some unwanted step can be removed, right? Can we simplify it, make it simple with minimum number of steps, minimum number of movements, minimum number of work, so that we will be able to finish that particular activity in less time. That is where we talk about this concept called the work study, right? Work study has three objectives. One is to make sure that your plant and equipment is effectively used, right? What do we mean by effective use? Effective use is optimal use. If a machine can produce 100 units, it has to produce 100 units. That is when we say it is working to optimal capacity. You understand that? If it is less loaded, like for example, if a machine is just having, is only producing 30 units, when it can actually produce 100 units, then we are under optimally utilizing it. Like for example, it can be a refrigerator or it can be a washing machine in your house. If your washing machine has got 6.5 kg capacity, 6.5 kg, 6.5 kilo clothes can be run in your washing machine. But if you're just putting one shirt and one pant, right? So it runs. Your washing machine is going to run, right? But it will consume the same amount of power. It will consume the same amount of time, right? So it means it is underutilized. Only when a washing machine is loaded to the optimum, then it does maximum function. Or even if it's a refrigerator, if your refrigerator has got so many shelves, it's got freezer component and all of that, and then if everything is optimally utilized, when it is full, then it is optimal utilization. If your fridge is only loaded only to 30%, only quarter loaded, then it's going to consume the same amount of power, same amount of energy, it's going to occupy the same space, so it's not effective. So how do we put the plant and equipment to full use? Second thing, employees who are working, how do we make sure that maximum human effort is extracted from them? So if a worker is going to come for 8 hours, he should be made to work optimally for 8 hours, which means he must have work for full 8 hours. If he has work only for 4 hours and the remaining 4, he does not have work to do, then you are paying him for 8 hours, but he's only giving you output worth of only 4 hours. So that is why how to keep a person fully occupied, like how your timetables are scheduled. Your timetables are scheduled to make sure that you are fully occupied for 6 hours throughout the day, right? So even if there are no subject hours, there are certain other extra value addition hours that are given, so that the maximum human effort that the time that you're spending on the campus, the time that you're doing all these activities are included, right? And the third is the evaluation of human work, to ensure that whatever work the person is doing is up to the standard or up to the optimal standard or the capacity that we have given, that bar or the target that we have given, which means you should be able to work for 8 hours, and 8 hours you should be able to produce these many units. Only then we say it's optimal amount of work, right? 3 objectives that we have to look into in each workstation. In each workstation, you need to ask this question, whether the workstation has been put to full use, whether the worker who's working is able to put maximum effort and is able to occupy that particular time and space in doing that job, and then whether that person is doing up to the expected standard that is set for him or her to do the job. So work study has 2 broad categories. We have method study and time study. Method study will look at what are the steps involved while doing a particular job, what are the steps involved. And wherever possible, we can cut down the step, we try to cut down the step. Then we look at something called time. What is the time taken for each workstation or work activity? So how much time does it take? Does it take 5 minutes? Does it take 6 minutes for producing one piece in that workstation? So if that unit, when that product is getting manufactured in one workstation, if it takes about 6 minutes, 6 minutes of time is the start and the finish time by the time it comes out of that workstation. You need to ask this question whether 6 minutes is the optimal time. Can that work be done in 5 minutes? Right? So if that particular work can be done in 5 minutes, then 1 extra minute that you are saving will contribute to reducing the total overall time, the total lead time that the product takes. So like that, in each and every workstation, you have to do these 2 things. One is trying to see whether the method that we are using is the best method, right? And if that is the best method, you standardize that method, which means you're going to train all your employees to make sure that they do it in that method only, because that method is the right method of doing it. So to find out what is the right method, we do the method study. And to decide what is the standard time, what is the standard time that needs to be taken for each activity, we do the time study. Okay, these 2 are what we do as part of the method study. Okay, so method study, it is a systematic recording, analysis and critical examination of existing and proposed ways of doing things, right? What is very important, right? A worker is going to do a particular activity. We're going to record it. We're going to analyze, why was this person standing like this? Why did he do this? Why did he do that? Why did he take that particular material? Or why did he do this activity before and that activity later? Right? We're going to analyze and critically find out whether this is the right way of doing it, right? And whether there is a better way of doing it. So we keep looking for a better way of doing it. So we select a job, we record the job, we examine, right? And then we develop, find out a better way of doing it. And then once we find out this is the best method by which we can do it. Earlier, the worker was taking eight steps. It was done in 8 stages. Now we are finding the same job can be done in 5 stages. So that is a better way of doing it, right? So that is how we do it. And once it is done, we accept that method. We standardize that method. We train all the workers in the factory, whoever is doing that job, to do it in that same manner. So that's why a lot of times when you go to factories, you will find workers do the same job and everybody will be doing it in the same way. And that is what is very fascinating, right? A lot of times our students are very absorbed in the way these workers are doing. They will be just seeing, it will be like captivating. You know, they'll be attracted to how this person is moving the hand, how quickly they are running the machine, and how quickly that machine is coming, the product is coming out. You know, they're standing there and just getting attracted to how it is done. And when you move from one workstation to another workstation, you will see almost the same, you know, the same kind of activity done by everybody. That is where we bring in standardization. So standardization and simplification are both concepts that will be very extensively used in method study. So we do that to find out what is that. Now, what is time study? Time study is just to find out what is the time taken for doing that particular work, you know, activity. So very similar to method study. Here, in method study, we're looking at movements and steps. What are the movements that the worker is taking and what are the steps that he is taking to do that particular activity? Here we are looking at time taken. What is the mental time involved, right? The thinking time involved by a laborer. So as soon as the material, raw material comes, what does he think, or time that he takes to think as to what needs to be done. Mental time. Manual time is whatever he is doing on that material. He's taking, is hammering, welding, or is painting, he's doing something over there. So how much time does it take in doing that particular activity in that workstation? Third is when this particular item goes to a machine, how much time does the machine take to bring out the output? So three areas of time observation we are looking at. One is mental time, time taken by the operator; manual time, time taken by the operator to do a certain value addition activity on that particular raw material or component; and the time taken by the machine. Right? So once we record all the three timings, then we try to see how we can reduce this whole work. Right? So we call this as work measurement. So what are the steps that we take? We take that job information is nothing but looking at that work activity. We break down that activity into different stages. What are the different steps? And then we take one sample, one particular activity or one particular worker who's doing that particular job. That sample will be taken, time will be recorded, and the mental time, the manual time, the machine time, all the three time will be recorded. Right? We do the same thing for maybe 8 workers. So 8 random workers will be called. All 8 of them will be asked to do the same job, and we will keep recording time. Worker 1, how much time did it take? Worker 2, worker 3, worker 4, worker until 8. So 8 workers time we see, and then we find out whether the time taken is common or whether time taken is higher or lower. Then we find out whoever is the worker who did it in lowest time. Then we ask that worker to repeat to see whether he can do it consistently. Right? And once that is done, then we find out if the output is the same thing that we expected and this person has done it in lesser time, then we see what are the methods involved, what are the stages he has gone through. And based on that, we take a consideration. Right? So we fix standard time only after knowing what is the time taken by an average worker. Right? Not the best worker, but an average worker. Where the best worker will always be able to produce it at a lesser time. Right? But an average worker is anybody working in that particular factory, anybody doing that particular job. If he or she is going to do it, they should be able to do it within that time. And that time is what we call as the standard time. Once the standard time is fixed, that is going to be that evaluative evaluation of human effort. That is going to be the standard time against which any performance of yours is going to be benchmarked. While we are doing this, we also calculate something called allowances. Right? So what you need to also keep in mind, a worker is not a machine. Right? A worker is not a machine. A machine can go on working for 8 hours and give you the same output in the same time. But a worker will not be able to do that. Because there is something called fatigue, there's something called tiredness, there's something called boredom. You're a human being. Right? So you will not be able to do it. In the morning when you come to work, you may be able to do, a lot more better because you're very productive, you're very fresh, you're very productive, right? And then whatever is the standard time, you're able to keep it up. But as time proceeds, by afternoon or by, slowly by the time it comes to closing time, you may not be as effective. So that's where we also need to keep allowances in mind. We need to take breaks. We need to ensure that the worker also feels comfortable, is also getting enough time, time that is spaced in between, gets enough breaks so that he or she is able to rejuvenate and then come back. And that's how we are able to fix standard time. Right? Now, why these work study and method study is important is because here we're trying to see how to reduce the total landed cost and the total landed time, which means the total time taken by the unit to move from the raw material stage till the time it becomes a finished commodity. We call this as the lead time. Now, lead time is extremely significant. Even if you make a difference of 1 or 2 minutes, if you are able to make the same commodity and you're able to save 2 minutes compared to the best competitor, your next best competitor, then 2 minutes adds on to 2 minutes on one item. If you're manufacturing 10,000 items, just imagine how much of an aggregative time saving that is going to give you. And whatever is time saved, you can manufacture more number of units compared to your competitor. Automatically, if the time taken can come down, automatically your cost also will show a gradual decrease. And then you are always in that very competitive position. You can become a cost leader, right? The price at which you are selling the commodity can be the lowest in the market if you are able to achieve the best method and the best time involved. Okay, so this is respect to one workstation. So like this, you do that for all the workstations that you have. Right from the time the raw material enters the first workstation till the time it comes out of the last workstation. Let's say you have 10 sequences, 10 different workstations. In 10 workstations, you should go and monitor each of the workstations and see how you can fix the standard time. Right? And once in all the 10 workstations, you have fixed the standard time, any worker who's coming in any shift on any day doing that particular job will have to do it at the standard time. Only then will a company be able to achieve its set target and then be able to create that optimal utilization in terms of cost and money, and then be able to give that benefit to the customer. Okay, so that is what this concept gets involved. We have a couple of problems which we will be taking up when we come back for the next class. A couple of problems we'll talk about work study and time study. It's all formula based. It's very easy for you to calculate how to calculate cycle time, and then how to ensure what is the optimal standard time that can be fixed. Right. So there are a set of formulas on work study, work measurement to determine time study. And then we have about 2 or 3 different problems that we can do that in class. And then you will know how exactly to cut down time. Okay. So this part we will do when we come back in the next class. It's a very important topic. When we come back, we will do that. All right. Any questions? Anything so far? Right. Last 2 minutes, 2-3 minutes. If you can turn on your videos,